Hi there, so this is a video showing how to construct and analyze a circuit in the PhET AC circuit construction kit. There's a DC circuit construction kit that we played with in the last video, but the AC construction kit has a special device called a capacitor that we're going to play with here. So take a moment to build this circuit that you see here. I have a battery that's connected to a bulb that's connected to one side of this device, which is called a capacitor. Again, to get a capacitor in my circuit, I just drag it out from this sidebar and connect it to these wires, and then my wires come around here to the other side of the battery. I haven't connected the other side of the battery quite yet. You'll see why in a moment. You can also see that I have the PhET voltmeter out here, and I also am using the non-contact ammeter. If you haven't watched the last video showing how to use an ammeter, you should do that before looking at this video, because this non-contact ammeter is kind of a special thing. They don't really exist in real life. They kind of exist, but not really. Anyway. I'm going to use this to record currents through different devices and different wires in this circuit. And I'm going to use the voltmeter to measure potential difference across different elements in my circuit. So we're going to collect data for 4 different changes. We're going to see how the circuit changes when I do 4 different things to this circuit. And it'll help us understand, like looking closely for patterns in this, in these changes will help us understand how this device, how the capacitor is working, and also why the light bulb lights up when it does. I'm going to show you how to do this for one of the elements in the circuit, and you'll then have to go through and measure the potential difference across in the current through other elements in the circuit. I'm going to make the measurements for the battery, and then you can make measurements for the bulb and the capacitor on your own. So notice if I hold this non-contact ammeter right next to the battery, it'll give me a current reading of the current through that battery, which right now is 0. And if I connect the voltmeter to 2 sides of the battery, it will tell me that the potential difference across this battery is positive 9 volts. Again, if you don't know quite how these instruments work, you should go back and watch the other video. But we're going to look at how these different values, how these 2 values change as I do 4 things to the circuit. I've made a little data table for myself here. You can do something like this, or you can record the data any other way that you think is convenient. These are the 4 things that I'm going to look at. I'm going to make these changes to the circuit and record data about potential difference and the current through the battery, the capacitor, and the bulb. I'm going to start out with the circuit not completed. That is, as you can see in this circuit, there's a break here. So the charges, these little blue dots, can't flow through the circuit. Then I'm going to connect the circuit with the battery. And you'll see the charges start to move. And then I'm going to make a measurement during that time, like while that's happening. And then I'm going to make a measurement after I've disconnected the circuit again. And I've noticed a change in the capacitor. And then I'm going to connect the circuit again without the battery. And look at how the circuit changes then. And I'm going to record values for the potential difference across the battery and the current through the battery for each of these. So I can make one of these measurements now. I notice this is 9 volts and this is 0 amps. So I will type 9 volts here. I also want to point out that this is not changing. It's staying at a constant value of 9 volts. And this is 0 amps. Also not changing. Then I'm going to connect this wire, and so I noticed a few things happen. I noticed that the current started at about 0.8 amps, and it looks like it's decreasing to 0 now. And it looked like this value, the potential difference across the battery, stayed at 9 volts the whole time. So I'm going to say 9 volts, not changing, and I'm going to say 0.8 to, I'm going to say decreasing from 0.8 amps to 0 amps. And now it looks like the charges aren't moving anymore. So this would be a good enough measurement for this. Now notice I have this space here for some other observations. I noticed that the light bulb was glowing, like temporarily. It's not glowing anymore, but it was glowing while the charges were moving. So I'm going to type that in here. The bulb lit up while the charges were moving through it. You may have noticed some other things happen too, and this would be a good place to record those other observations as well. Like if you noticed any changes to the capacitor, that would be a good space for those. Now I want to go on to the next thing. I'm gonna disconnect the circuit by doing this. If I click on that, if I right click on that, I can separate the battery from the circuit. I'm actually going to do that to both sides of the battery. So it's completely separated from the circuit. And I'll measure, let's see, I'll measure the current through the battery now is 0 amps. And it looks like the potential difference across the battery is still 9 volts, not changing, and this is 0 amps, not changing. So then the last thing that I want to do is connect the circuit without the battery. So I'm going to connect this here. And I noticed the light bulb light up again while the charges are moving. I noticed some interesting stuff happening down here, but these values didn't change at all. Looks like when the battery is not connected to the circuit, the current through the battery is still 0. The potential difference is still 9 volts. But I was able to light the bulb without a battery, which is pretty fascinating. 0 amps, not changing. So again, you're going to want to do this again, like build the circuit and make the changes that I just made. You could, if I just split this, I can actually connect the battery right back in again. I can do the same thing over again, but I could measure the current through the capacitor, for example, and the potential difference across the capacitor. So I could make these measurements for the capacitor, and then I could do it all again for the bulb. After you do this, you're going to want to think carefully about any pattern that you see, and see if you can use this pattern to help make a prediction of what might happen, or how this circuit might work if instead of having just one capacitor connected here, you connected another capacitor right next to it. That is, like if I took out some wires and connected this side of the capacitor over here and connected this side of the capacitor here. You should be able to, if you look at your pattern carefully here, make a prediction of how this circuit might work with two capacitors right next to each other. This is a more complicated circuit, and you could go through and you could make these same measurements for that circuit as well. But we want to use our measurements in this first case with just the one capacitor. Let me get rid of this stuff. To try to form an idea of how this capacitor is working and why the light bulb lights up when it does. All right, good luck and have fun.